Hey, how y'all doing? This is OXDF, and today we're going to start talking about Rust. I've wanted to dive into a new programming language. I enjoy programming, and um, I've been focused on learning and getting better at and doing things in Python for so long. I would say 95% of my programming experience at this point has been in Python, and I really thought it'd be beneficial to me to dive out and explore something new. Rust is a programming language that is really popular right now. It's a compiled language. It's very fast. It's being used for a lot of Python plugin development, but it's also very safe and really prevents you from putting things like buffer overflows and stuff in your code. So I thought this might be a good one to start with. To learn it, I'm going to be going through the 2015 Advent of Code challenges. I solved some of these in the past, but I've never worked all the way through them. And I thought that may be a good place to dive in and take a look. In future videos, I'm going to be going through those challenges. I won't be getting a video out every day, but maybe a couple a week. We'll see how far I can go in this. And in today's video, I wanted to do an overview of kind of what I've learned so far, enough to get started in the Advent of Code challenges. And hopefully it's enough Rust for you that if you're following along and you've never seen Rust, that you can at least watch the other videos and have some clue what I'm doing. And it'd be awesome if anyone wanted to try to work this alongside me. Leave a comment down here and, get started and find some free time to start learning Rust as well, and we can compare answers, or you can leave me comments in future videos and tell me what I missed or how we could have done it better. I'd be totally into that. So today's video, we're just going to kind of go into some background. If you're getting started in Rust, you're going to want to start with this thing called the Rust book. There's copies of it on Rust's website, rustlang.org. But I actually really like this version that's hosted over here on the Brown University Computer Science Department website. There's a few little things. Let me see, if we go to here, as you go through, there are quizzes. I pick the one page that doesn't have any quizzes. Let's see, yeah, so here's some quizzes here. They'll quiz you as you go along. That's not in the main book. There's also some cool things where you can say, you can highlight things and say this is neat. And if you put this comment here, now it shows up. And even if you click away and then come back, it would be there highlighted in yellow, and I could still see it. So it's kind of a neat little note-taking ability. So with that, let's go ahead and take a look in VS Code at where we're going to be working. You're going to want to install, if you're working in VS Code, the Rust Analyzer plugin. This is the official plugin, gives you syntax highlighting, autocomplete, that kind of stuff. So that's, you're sure going to want to have that installed. Yeah, with that, typically here I would start with Hello World, but actually we're going to talk about Cargo. Because if you're going to work in Rust, you're going to use Cargo. And that's like the build system and package manager for Rust. And when you install, the instructions in the Rust book will show you how to install, and it comes with Cargo. So if you see down here, we're in a Advent of Code Rust folder. If I start Cargo new, and we'll call it project intro. This last one is just the name, whatever we want to call it. So we'll call it intro. And so it creates this intro package, and you can see up here, it created this folder. There's a Cargo.toml file. There's the source directory here with a main.rs. There's a git ignore file. It actually creates it. I don't know why it doesn't exactly show up here, but I think Visual Studio Code is hiding it from us. We could look ls-la intro. Oops. Try this with la intro. So there is a .git folder. So this is a Git repo now, which is nice. If you actually have a Git repo up at this highest level, it won't create a new Git repo inside of that. It's smart enough to check for that. And that's probably how I'll work. I'll have one Git repo for all these solutions, which I'll also try to include in the comments or in the description down here. So, okay, so we've used Cargo new to create a project. This Cargo.toml file, if you're building like a big application, this is where you put in your versioning information and your other things like this. What we're really going to need it for in this introductory phase, and as we're solving Advent of Code challenges, is dependencies. If you want to use an outside package that's not necessarily part of the core Rust code base, you're going to need to put dependencies in here, or else it won't compile. And then when you do go to compile it, it'll yell at you and say, oh, this is a dependency I don't recognize. Make sure you update your cargo.toml file. And so then you'll go do that here. And if you're not familiar with TOML, it's just another language. It's like, JSON or YAML, or it's a formatted language for storing data. So we also, with this cargo new intro, we created a source folder, and in there is main.rs. And this is a nice, simple, every time you create a new project, you get a free Hello World application with it. And we will take a look at this in more detail in just a second. But first, we're going to talk about, so we can also now that we have this, let's see, we'll go into the intro folder and we'll do cargo build. And this just compiled my source code from the source folder into, you'll see a new folder appeared here called target. And so when I look in the target folder, I have this target debug, and there's a bunch of stuff here that was used for building, but I also have this intro. And so if we, let's see, if we go into target debug and we do file on intro, and you'll note this intro matches the name of the project. So I started a project called intro, now I get a binary called intro. And it is a ELF 64-bit executable. In fact, we can run it and it prints hello world, not unsurprisingly. So with that, I guess one other note to say, you'll see this is building in the debug folder. If I ever wanted to like actually build something for production, I would do cargo build and do dash release. And it's going to build that into the release folder. And this is going to be a slightly different version without the debug information and stuff that like you might pick up with GDB and things like that. With that, let's take a look at the actual code itself. In Rust, a function starts with fn. That's how I define a function. And every project or every project is going to have a main function as the entry point. And so that's what we have here. Now this main function literally has one line in it, this print line. And this is actually a macro. There's functions and there's macros. From a high level, when you're approaching this, you don't really need to totally understand the difference between a function and a macro. Other than macros end in exclamation point and functions do not, and we'll create a function in a second. The big difference is when I go to compile it, a macro is going to be handled at compile time, and it's going to break it apart and make the pieces it needs there. A function gets built into the binary, so it can actually get called from there. So the other important thing is a macro can have a variable number of arguments. So I can do another print line here, and we could do this, for example, can take this syntax where we can say hello that, make sure we get our string, and we say oxdf. And now, oops, let's put the exclamation there. We will go and build this again. And then we can do target debug intro, and run this. And now we have hello world, hello xdf. A function is going to have a fixed number of arguments, but this, you can see right here, here's hello world with one argument, or print line with one argument, here's print line with two arguments. The macro figures all that out at compile time. So macros can actually be much more complex than functions in that sense. There's one other thing with cargo that's worth going over, and I mentioned this earlier. Doing cargo, you saw that right there, it's kind of annoying. I had to go build it again, then I had to go find the binary and run it. If you're at the root of the project and you run, cargo run, it'll build and run it for you all at once. And so this is incredibly useful when you're debugging and when you're running, so solving advent of code challenges, you want to just hit save here, come down here and run cargo run. And so that's what we're going to do most of the time. Okay, so back up here, we might want to have a variable. So in Rust, you use the let keyword to make a variable. So we can say like let name equals oxdf. Semicolons are required to close lines. Talk a little bit more about that in a second. But we can come down here and we can put name here. And one thing, it's actually kind of cool. You see this right here, I didn't type this part, but this is implied typing. So VS Code is recognizing that I'm assigning a string object to name. So name must be a string. And so it's just sort of calling that out for me. Let's go down here and run it again. And you can see that worked just fine. I can also explicitly put the typing in there. And so if I do like that, yeah, so there, that looks like that. We could show another example here. If we come down here and do let num, and we'll do like use 64. So an unsigned 64-bit integer. If I say that equals 5, and then I do print line num. And I can even, I'll show you, this is another way we can do inline, with this print line macro, we can do inline variable expansion like that. And we can save that and we can run. So that's all looking pretty good. one thing we need to know about variables is that variables in Rust are immutable, which means we can't change them. So if we want to come down here and do something like num equals num plus 1, and now we want to print line and say like new num, save that, and run it, and it's going to fail. And so we get some errors here. The Rust compiler is pretty good about giving us good errors. So it's saying cannot assign twice to an immutable variable. So variables are immutable, means you can't change them. You set them once and they're fixed. So how do we fix that? Well, if we want to be able to change num, because it's very common, you're going to want your variables to be able to change, you just need to add the mute keyword here and say like this is going to be a mutable number. And so now if I run that same thing again, you can see down here we got our num and then we got our updated num printed just fine. All right, so we may also want to add some functions. So, oops, I didn't mean to make that. We can make our own functions. So we can do like get num. And oops, let's see, this makes my Python habits coming through already. And so we could do something like return 5. And so it's down here, instead of this, we'll do get num like that. And I think this is actually going to fail. Let's try it. Yep. So this is important here because when you create a function, so with the variables, I showed you we could type that by saying this is going to be a string. With a function, you're required to. So this is going to return, say a U64, because that's going to match that type down there. So if we save that, and now it runs fine. So now it's happy. We've told it that we're returning a U64. In general, in Rust, you want to use snake case, so all lowercase with underscore separating words for functions. That's just how they like to do things. Yeah, we must declare not only the return type, but if there was going to be an argument, so we could do like function incnum for like increment, and we would take in I, which is a U64, and we would return U64. And we're going to do return I plus 1, like that. And if we save that, now we can come down here and we can say num equals inc num. And I think this will work. And so again, now we've made this function. If we didn't put this here, it would throw an error and be unhappy with us like that. So it's a good break to talk about statements versus expressions. Statements are instructions that perform some action and don't return a value, and they end in a semicolon. So here we stored the value OXDF in the variable name. Nothing got returned. It just, that stuff happened and we ended it in the semicolon. Here we printed some stuff, but we didn't return any values. No values were returned. So these are all statements. Expressions evaluate and result in a value. And the way Rust is preferred, I've showed off this keyword here, but I actually can come over here and just put the word number 5 here. And it's because it's an expression, it returns something. And because it's the last thing returned out of this function, it's going to return from the function. And so you see we can run this and we're still getting num of 5 here. It's important to note, if I put a semicolon here, now it's a statement and now it doesn't return anything. And now it's going to error because you can already see its syntax. It's pointing out that it's not returning anything here. Similarly, if I try to do a return without a semicolon, it's going to say, that should not have worked. Did I not hit save? All right, that will yell at you sometimes. I don't know why it's not yelling at you here. Does it work down here? All right, weird example. I guess that does work. But in general, you're better off having your semicolons there. But really what you want to do when you're writing Rust is have your last line of your functions be a expression. So you can just do something like that. And that is the Rusty way to do it. I forget what the hell they said, Rustian, something like that. All right, let's talk, what else could we do? Loops. So we'll come down here and we can do a loop. So we can do something like this. Also, it's got the standard loops, while for, there's just a plain loop that's basically a while true. Then you have break and continue and the same kind of keywords you'll have for loop management from any other language, but we can do something like for C in oxdf.chars. So that's going to take that string and break it into characters, and then we put it in squiggly braces, and we can do print line, we'll do like that. And if we save this and run it, and you can see now at the bottom, we're printing 0xdf. We can also do things, one thing that Rust does like to do is because, this oxdf.chars was returning a vector or an array of characters, I can now just take that array and chain together functions. This is kind of JavaScript-y. So if I put an enumerate here, now you can see right here, now it's already saying, this is Visual Studio Code telling me, oh, now C is going to be taking a U size or an unsigned integer system size and a character. And so I may want to do something like I comma C like that. And now it's saying, oh, I is going to be an integer, an unsigned integer, and C is going to be a char. And so now we can come down here and say like I colon C, and if we save this, we'll see it runs, and now we see 0, 0, 1x, 2d, etc. And so we can chain things together here. Let's see, outside of loops, another thing worth talking about is in Python, I would deal with classes, and I'd write a class that would have some objects. And so I'd write a class that defined it as kind of an object, and I would create instances of that object, and that object could have values associated with it. It could have functions or methods associated with it. And we can do the same kind of thing here in Rust, but it's a little bit different than I'm used to. So we're going to do something called a struct. Let's say we do like rectangle, if I can spell. And let's say it's got a W that's a U32 and a H that's a U32. So this is kind of like a width and a height, right? That's what a rectangle has. And so we've defined a rectangle. And see, this is VS Code even telling us like we've not used it any times, but we've defined it. So we'll come down here to our growing main section here, and we can do let R1 equals rectangle. And then we're just going to come down here and do W, let's say 4, H10. And we need to put a semicolon there at the end. You can see Rust was there, the linter was yelling at me about that. And we can now do things like print line, and we'll say like the rectangle is blank by blank, comma, and then we can do R1.W and R1.H to reference those. And if we've not screwed up, we will get a nice, here our rectangle is 4 by 10. So that's kind of neat. I also may want to have functions here. So like, let's say we wanted to define like an area. A rectangle should be able to report its area. You actually define that down here with the impl keyword. And so we're going to say rectangle implements, and then we're going to put the function here. So we're going to say function area, and it's going to take self, and I'll come back to that ampersand in just a second, and it's going to return a U32 because that's what we're working out of here. And we will do self.width or .w times self.h. And we're going to not put we're not putting a semicolon there because we're just going to return that value. And so now we come down to our bottom here and do print line. Its area is, comma, and then we do r dot area. Oops, r1 dot area. I think that's why we're not showing up there. Does that work? r1 dot area. There we go. And we save that, and we run, and now you see its area is 40. So it did the multiplication. So that's the real basics of defining a struct and then putting some functions or methods on it. The one thing I wanted to show before I dive in is I wrote this kind of silly bash script here to get myself started specifically for Advent of Code stuff. If you go to Advent of Code and you look in your browser and you look at the cookies, you can actually pull out your session cookie because you're going to need that to get your specific stuff. But basically what I'm allowing myself to do here is this right here is basically just saying strip all leading zeros off of the first argument passed in. So I'm going to get a day, which I can put leading zeros or not. It's going to strip them down. Then I'm going to create a project, which is going to have exactly 2 digits. So that way I can run 0, 1 through 25. I'm going to get the session out of my environment variables. I just didn't want to show you all mine here. I'm going to create a new project called, in this case, like day 01. I'm going to go into that directory. I'm going to fetch myself the input, and let's see here, how do we wrap this? Word wrap here. I'm going to fetch myself the input for that day. I'm going to pass it my cookie, and I'm going to write it to input.text. That way I just have the input. And then I'm going to go ahead and update, they gave me that nice hello world. I got this silly, kind of silly stub that I found for Rust. So from within the directory, it can know to get input.text. And then I've got just sort of my print lines for part 1 and part 2. And so I can start putting, this will just overwrite the basic, and that'll allow me just kind of quickly to get started going. The one other neat trick about this script is I'm going to run it, instead of running the script itself, I'm going to source the script, or you can do dot space the script name. And when you do that, things like CDing into the project folder will happen within your current context, not within the subshell created by running the process. When I just run the script, it would CD into the directory, do the stuff, and then return, and I'd be back where I started. But now I'll actually be in that directory. So that's kind of neat. So if you'll see me do things like oops, that's not the right place. Gen day.sh1. Oops, we're not in the right folder. Here we go. And so now it's created the day01 package. I'm now in day01, and I've got, if we pull up, let's see, if we look at the source here real quick, we can see, there's my source. So with that, I'm going to call it here. Take a look at the Rust book. Leave me a comment if you're interested in trying it, and hopefully you're interested in coming along with me on this journey. Thanks, and I'll talk to you next time.